Hello everyone. This video will show how to evaluate limits given a graph. So let's take this example right here. So this is the graph of the function g of x. Looking at the first problem that we have right here, we're supposed to find the limit of g of x as x approaches -4 from the left. So tracing -4 on the x-axis, it should be on this spot. That's -4 right there. And we're supposed to trace the graph from the left towards x equals -4. So as the x values approaches towards -4, our f of x gets closer and closer to -1. So the limit of g of x as x approaches -4 from the left is -1. For the right-hand limit right here, we are supposed to determine the limit of g of x as x approaches -4 from the right. So we're going to trace the graph. As x approaches -4 from the right, our f of x gets closer and closer to -1. Now for the two-sided limit right here, this is read as the limit of g of x as x approaches -4 from both left side and right side. So we can go ahead and say that the value for the two-sided limit is -1. It should be noted that two-sided limit exists if and only if the left-hand limit and the right-hand limit are a match. So in this case right here, both are -1, so the two-sided limit is -1. Now let's have the next example right here. We're supposed to find the limit of g of x as x approaches -2. So that is -2 right there. And we're supposed to trace it up on the graph up there so that we go ahead and trace the graph from the left side. So the x from the left side approaches towards -2. The f of x value gets closer and closer to 7. On the other hand, if we find the limit of g of x as x approaches -2 from the right, as the x value approaches -2 from the right, our function gets closer and closer to 7. Now notice that both the left-hand limit and the right-hand limit are a match. That tells us that the two-sided limit is 7. Now let's have the next example. So we're supposed to determine the limit as g of x approaches 1 from the left. So 1 is right here. So as x approaches 1 from the left, our f of x gets closer and closer to 4. On the other hand, if we have the limit of g of x as x approaches 1 from the right, as x value approaches +1 from the right, our f of x gets closer and closer to -3. Now notice that the left-hand limit and the right-hand limit don't match up. So this tells us that the limit of g of x as x approaches 1 from both sides does not exist. So to sum it up, if the left-hand limit and the right-hand limit are a match, then the two-sided limit exists. Now, if the left-hand limit and the right-hand limit don't match up, then the two-sided limit does not exist. Now, let's have another example. In this example, we're supposed to find the limit of g of x as x approaches -infinity. If we trace the values of the x towards -infinity, we're interested to determine the value of the function where does it approach towards as we go infinity. So we can go ahead and say that this will continue to go down all the way to -infinity. On the other hand, we wanted to find the limit of g of x as x approaches positive infinity. That would be on the positive x-axis. So as we go towards positive infinity, our function will approach also towards positive infinity. On the next problem that we have right here, we're looking for the g of 1. So this notation tells us that if our x is 1, what is our y value? So in this case right here, we're going to trace it on the graph. This is 1 right here. And what is the value of y on the graph? And that would be 4. This notation tells us that if x is negative 4, what is y? So negative 4 is right here. What is our y value? Since this is an open circle, it does not exist. So that is how we evaluate limits using a graph.